We are in chapter 5. So here we will be learning about the primitive data types in Java. See, if you want to learn any language, first we need to know the data types which is available in that particular language. So Java is an object-oriented programming language, and it has some kind of primitive types which we need to know about. So let's look into that particular primitive type now. See, there are like 8 primitive types. I'll just go to our presentation. There are like 8 primitive data types which is there in Java, and we need to look into that. So there are 4 integer data types and 2 fraction types. A number which is going to have decimal point, and then there is one character type, and there is one boolean type. So totally there are 8 data types which is there, primitive data types in Java. So if you want to do commenting in your Java code, so we will be using these kinds of comments. A C style comment is available, a C++ style comment is available, and then there is a Javadoc comment which starts with /. We'll talk about Javadoc later, where there is a provision in which you write documentation to your code inside the code itself. And there is a tool called Javadoc which can read your documentation and generate an HTML documentation for you. Read the documentation which is there inside your source code and generate the HTML for you. That kind of HTML is what we are seeing as the Java documentation. So what is a variable? So when you are going to declare variable, you need to declare variables based on the type, the primitive types what we talked about. So still we need to learn more on primitive types, but variable declaration, just look at the code example which is there at the bottom. Your variable names should be meaningful. So there are some tips based on clean code concepts. The variable names what you are going to declare, look at the way how it is declared. So if there is two word inside your variable, the first word, first letter is a small letter. Second word, subsequent words, first letter will be capitalized. Look at the second example, certified Java programmer. J and P is going to be like capitalized. Another thing what you look in these variable declaration should be meaningful, and very important, it should be pronounceable. So your variable should be pronounceable. So look at the certified Java developer. Some developers will write like boolean CERT Java PROG, like that they will write. I'll write the example. Say some people write like this: CERT Java, what is the other one, programmer, PROG. See, this is not pronounceable. This is not pronounceable, and don't define variable names like this. Okay, so define variable names which is pronounceable, human pronounceable. That's one best practice what you can take care when you are going to write code. So why we are doing this? Because if anybody is going to read your underlying code, it will be easy for them to visualize or memorize your underlying variable names. Other thing what we should take know is like Java is a strongly typed language. What I mean by strongly typed language, any variable which we are going to use, that particular variable type we need to declare definitely. Any variable which we are going to use, that variable's type definitely we should declare. So that's your strongly typed language. How the variable names can be. So the top code block is valid variable names. A variable can start with dollar, and it can start with any alphabet, capital, small, it can start with underscore, everything is fine. What are all the ways in which you cannot declare variable? A variable cannot have a hash. A variable cannot start with a number, numeric value. A variable cannot have an operator, minus, multiplication, and all those things. A variable cannot be a keyword. Abstract is a keyword in Java. So use meaningful names. That's the best practice what we should take care. Some reserved keywords in Java. We don't want to go through all those things now, but as chapter by chapter we will learn all these keywords. So variable types, that's going to be your primitive data type at present. Later we will be talking about the object types. So these are all the 8 primitive data types which is there in Java language. So there are 4 integer types as we saw previously, and these 4 integer types are like byte, short, int, long. And there is one character type which is going to be char, and there are like 2 decimal types which is float and double, and there is one boolean type which is like true or false. It can have value like true or false. Let's come back to our primitive data type of integers. There are four integer types. So what do you mean by that? A data type what you can use which doesn't have a decimal point. So there are like byte, short, int, and long. So we need to exactly remember in this particular order, because each and every variable type is going to have some kind of say boundaries. How much data how much values it can hold. So byte is a signed 8-bit integer. So all primitive types are signed data types in Java. So in C, if we see, there is unsigned and signed data types. In Java, everything is a signed data type, and byte is a signed 8-bit integer, and short is a signed 16-bit integer, int is a signed 32-bit integer, long is a signed 64-bit integer. So there will be a negative part as well as positive part which is going to come for these integer types. Let's go to the tutorial which is available in Oracle site, which talks about this primitive data type, and look at the explanation for each and every primitive type. First, starting with byte. So it tells that it's an assigned 8-bit integer, and its maximum value is minus 128 and minimum value is 127 inclusive. So normally how these things are calculated, it's like so byte, it's an 8-bit signed 8-bit. So signed 8-bit means what? 2 power 7 to 2 power 7 minus 1. So 2 power 7 is like 2 into 2 into 7 times you need to do that. So 2 into 2 into, if you do 7 times, you will get 128. So this is going to be like minus. And positive side is 2 power 7 minus 1, which is 127. Right? So if you are going to declare byte, it should be within this particular range. So you cannot define a byte which is going to be beyond this particular range. If you try to do that, then you may end up with the compilation error. Let's try to declare and have a look into what kind of say problems which we are going to get. So I am just doing this in Eclipse, and let's do byte b equal to 130. So when we declare 132 byte, so there is a compilation error which tells that type mismatch cannot convert from int to byte. But the same thing when we declare like 127, and this is fine. So that's the range of the byte what we talked about. Similarly, we have ranges for short, int, long. So it's assigned 16-bit integer. What do you mean by that? 2 power 15 minus 2 power 15 to 2 power 15 minus 1. So that's your signed 16-bit. Signed 32-bit minus 2 power 31. So 2 into 2 into like that 31 times you should do. You see how big that number is going to be. And then in the positive side it will be minus 2 power 31 minus 1. Similarly, this is minus 2 power 64-bit, right? So these are all the lengths of these primitive types, these integer types. Then you got the decimal type. So let's look into this decimal type. Float is defined as 32-bit single precision. So it is 32-bit means what? 2 power 31, right? That's the value what it can have. What do you mean by just single precision? Let's see an example. So I declared a float here with a big decimal value. So after decimal point, we have given a lot of number, and other thing what we should know is like when we just declare a float like this, we may get a compilation error which tells that type mismatch, because it's giving it as double, it's taking it as double. Although I'm going to give a small value after the decimal point also, it is taking it as double, right? So in order to make this float, I need to put a I need to put a character like f, which will define this as float. So I'm going to give a big value. And then similarly, double is 2 power 63. So if you see here, double is a 2 power 63, double precision. This is what we are going to understand now. What is a single precision and double precision? So double, we have declared a big number here. So just for clarity, not like a same number. Let's do a different number. Let's do done a different number now. Now let's print this float and this print. Let's print this particular double and see what kind of output we are going to get. So the first thing, the output what we got after decimal point, we got only 6 characters which is displayed. So single precision is like including decimal point 7 characters it is getting. Double precision including a decimal point you should get 14, 15 or 16 characters. Let's see. So this is like 3, this is like 6, and this is like 9, and this is like 12, and this is like 15. So 16. So including this decimal point, it's going to be like 16, right? So that's the kind of length what we will get for float and double. If you have calculations which is going to be precision or beyond these numeric values, these values, say there are some astronomical calculation in which 2 power 63 won't be enough, right? So they are all defined with the higher numbers. Then we got like two object types which we can use, like big decimal and big integer. Right, these two are the object types which can be used to represent a numeric value which is beyond the length what we have seen here. So which is going to be beyond these length, big decimal and big integer. Boolean, straightforward, true or false. There is no other value what we can have. Last one is the char type what we need to know. Every character in Java is a 16-bit Unicode character. 16-bit is 2 byte, right? So it's going to occupy 2 byte in your underlying memory, and it's a Unicode character. What is this Unicode? Let's see. We'll go back to our site where let's go and see the char. The char data type is a 16-bit Unicode character, and the Unicode are represented like this in a single code /u, and there will be like 4 numbers. And what is this particular Unicode? So initially the numeric system, the numbering system in computers was defined by ASCII, American Standard Code for Information Interchange, and this had only English characters. Later in 1990s, other world countries like China, Japan, this China, Japan uses their own language like Mandarin Chinese and Japanese language to do every kind of work. They don't use English as the major language. So these countries majorly they want to use their characters also as a part of the numbering system. So they want a numeric representation for Chinese characters, they want numeric representation for Japanese character. So there was an organization formed called unicode.org who started providing standards for including all the world language characters. So Unicode currently has representation in Chinese, Japanese, and all those things, even in our regional languages like Tamil, Telugu, Hindi, right? All these languages, Malayalam, Kannada, every language is represented by Unicode. So let's go to a website and see about this particular Unicode. I will just open unicode.org. So this particular unicode.org is a non-profit organization who started building standards, right? And you can get the underlying information about Unicode, and then what kind of character and all those details are available here. Simply like a Unicode Tamil, if you see. So there are a lot of resources which can define the Unicode in Tamil. So my spelling is wrong. Right. So this is all about the char type what we have in Java. Right. So the next chapter will talk about the arithmetic promotion and basically about operators and what is this arithmetic promotion, how we are going to make use of these variable types. So that's what we will be talking about in the next chapter. So this is very, very important what we have seen now, and every Java developer should never forget these values, right? These primitive types and its corresponding ranges. Definitely we should remember all these things. Thank you.